and go. All right, we are on lesson 2-1, AP Calculus, Basic Power Derivatives, our brand new unit. This unit is all about taking derivatives. Today's date is Wednesday, September 19th, 2020. Our objective today, who would like to read that? Yes, Chris.
Find derivatives of functions using the different forms of negative exponents and radicals.
All right, and you guys did this unit last year, so you guys should be, you should have this down, right? Okay, so x to the power of -4. How do you rewrite this with a positive power? Because negative powers are okay, but I just need to practice. How do we get rid of the negative and turn it into a positive power? Remind me that you passed Algebra 2. How do I rewrite this thing? Oh, no. Yes, Teflon.
Is it 1 over x to the 4th?
It is indeed 1 over x to the 4th. Yeah, thank you. What about this one? 1 over x to the -3 turns into what? Yes, Fiona.
X to the 3rd.
X to the 3rd, perfect. Ooh, okay. And this one is the one that that most students make mistakes on. 2x to the -8. How do I do this one? Andrea.
Is it 2 over x to the 8th?
Ah, you got it. I hope that someone got tricked by it, but it wasn't you. It is 2 over x to the 8, which is important because this negative exponent only applies to the x. It does not apply to the 2. Do not move the 2 unless it has its own negative exponent. Leave it in the numerator. That is a common mistake, but now hopefully you guys will not make it as much. Okay, so in words, to switch the exponent from a negative to a positive, only move the thing, what's that word, between the numerator and / denominator. What is that, another name for x? Who's got it? What is x called? It is a type of, starts with a V. It's a word you learn in Algebra 1 or 8th grade or even before that, I don't know. No? Teflon.
Variable?
Variable. Yes, only move that variable. And specifically, I guess I should write this too, not the coefficient. So I'll write up here, not underlined the coefficient. Maybe an exclamation mark is appropriate there too. All right, so let's practice getting rid of radicals. Turn radicals into a rational exponent. So x to some power. So square root of x is x to what power? Yes, Fiona.
Is it x to the 1/2?
It is indeed 1/2 because whenever you have a square root, it's a hidden index of 2. And whenever I have an x, it's a hidden power of 1. So to the power of 1 divided by 2. Yeah. Okay, what about the cubed root of b? Someone aside from Fiona. Andrea.
B to the 1/3.
It is indeed b to the 1/3. Again, we have a hidden 1, so b to the power of 1 divided by 3. And then what about this one, x? So it's the 4th root of x to the power of 3. Someone aside from Andrea and Fiona. So Chris or Teflon, do this one.
Is it x? Actually, I don't know.
Okay, Chris did the hard part. Now Teflon, you do the rest.
Wait, is it 3 over 4?
Oh, okay. Chris got the hard part here. Yes, it is 3 over 4. Next time, Chris, if you could raise your hand, I'd appreciate it. Yes, you got it right, so Chris.
I forget.
X to the power of 3/4. All right, so these are the 2 different ways of writing derivatives. I'm not going to spend too much time because you guys have seen this a ton. This f prime of x, you know that this is called f prime of x, but let's write it in our notes too. This is f prime, not Amazon Prime, but f prime of x. That is how we read it. And the next one, d dx, I mean, a lot of people pronounce this d dx, even in the professional mathematics world, but the correct way of pronouncing this is, if I'm taking, this is saying the derivative again, the derivative of something, so maybe you want to write your something as an empty box. So the derivative of something, this is saying the derivative of x, I guess, the derivative of that function. This is pronounced derivative of whatever that box is thing. So of that box thing with respect to whatever this variable is. So with respect to that variable down here. So in this case, it's x. Sometimes it's with respect to y, and those do happen very frequently, especially when we hit unit, I can't remember, it's like 6 or 7 or something, sometime when we start doing for response. And I should end my quotes too. Chunk, chunk. All right, so the constant rule. Whenever I have a constant, which is like a number with no variable, it is always equal to this one thing. Do you guys remember from last year? The derivative of 5 with respect to x is some number, and it's always the same number over and over and over again. You remember what number that is, Fiona? Ooh, close. It's the other number. Yes, 0. And help me pronounce these things. Is there a quiet raised hand that can tell me, how do I pronounce this thing? It's not d dx of -2. It's pronounced this way, up here with the quotes. Who can help me pronounce this? Get in the habit of saying them out loud again. Teflon, you want to do it?
Derivative of -2 with respect to x.
Beautiful. All right. And then what is that, Teflon? The derivative of a constant is always
0.
0. Yep. And then Chris, how do I pronounce this thing over here? This d dx of k.
Derivative of k with respect to x.
There it is. Yeah. And I put this in the homework too. But k, if there's no x, there's no this number in the bottom, then it's a constant. If this was an x, then that would be the variable. But this k, k for constant, it represents a constant. So I don't have enough room. I'll do it down here. This is a constant. Sometimes you can have variables that represent a constant, even though it's technically a variable. Since we're taking the derivative with respect to a different variable, this is considered a constant. And therefore, Andrea, the answer is?
0.
0. All right. And Fiona, what should I put down here for our rule? The derivative of a constant is? 0. And if you're super clever, you'll go ahead and annotate this like that. So it looks like a K, because it's hilarious. Because I don't know why in all of AP Calculus we use K for constant. We should use C, right? Although we do sometimes use C. Linear rule. Okay, so what happens if I just have an x? No x squared, no x to the power of 3, no 1 divided by x, just purely an x in the numerator, 3x, -2x, stuff like that. What do I do? Yeah, Fiona remembers this one. Go for it.
1.
Ooh, so close. Not 1. It does depend on what this looks like. The derivative of 3x is different than -2x.
Is it 3?
It is 3. What about the derivative of -2x with respect to x? What is this equal to? Teflon, who's very much awake, I can tell.
-2.
It is indeed -2, yes. Ooh, this one is a little bit harder, though. First of all, how do I pronounce this thing? Quiet raised hand. Who can pronounce this thing? Who hasn't pronounced things before? Andrea?
The derivative of 12x plus 1 in respect to x.
Perfect. All right. And you can do this one or you can give it to someone else. What is that?
Is it 12?
It is 12. Technically, it's 12 plus 0 because the derivative of 12x with respect to x is 12 and the derivative of 1 with respect to x is 0. But yeah, just 12. And I'll box that 12. All right, and our general formula, the derivative of something x with respect to x is that something. Cool. And we're on to the back side, which is going to be pretty quick. Did I add the extra examples? I did. Good job, Mr. Sindel. I improved the notes from last year. All right, so then we have the simple power rule, which is kind of the biggest, most important one that you need to know. I wonder if anyone can remember this. If I have n as an exponent, it moves somewhere, gets added or subtracted. Do you remember what the general rule is? Yeah, Fiona again.
Wait, never mind.
All
Oh,
right,
wait,
someone help her.
is it n times 1? Like, you
Yep.
multiply it.
N times, and then 1.
X.
X
O to the n minus 1.
to the power of n minus 1. You remember it. Very nice. Yes. Give me a thumbs up in your camera if you kind of remember that one from last year also. Andrea's got it. Teflon is reviewing it, kind of. And then Chris, where you at? Is that a kind of review? Thumb in the middle, thumbs down?
I have short-term memory, bro.
Okay. We need to turn that into long-term memory. Yeah. So, and the more general formula that I might want to write down for next year is this one. So if I take the derivative with respect to x, so d dx of a instead of 1, ax to the power of n, that means I'm going to, again, I still have the n that's going to be brought down in front. So it's going to be n times a. So n times a, and then you rewrite the rest of it, x to the power of, and again, n minus 1. You always subtract that power. So just multiply those first coefficients, n times 1 or n times a, and then always go down a power. And you guys already remember this because you've gone backwards before. Going backwards means I add a power and then divide down, but now I multiply down and subtract 1. All right, so let's do these rapid fire. We'll do Teflon, then Chris, then Andrea, then Fiona for the first 4 examples. So Teflon, you're up first. X to the power of 5. I'm going to take the derivative of that with respect to x.
5x to the 4th.
Beautiful. 5x to the 4th. Chris, you're up. The derivative of x. Oh, wait. I should make everyone pronounce them too. Chris, first pronounce this thing. How do I say it? And then also answer it.
Is it the same way? Just to pronounce it the same way?
Yes.
The derivative of x to the 40th? As x, wait, as what was it?
With respect.
With respect to x.
Perfect is?
40x to the 39th?
Beautiful. Yep, you got it. And I said Andrea was next.
The derivative of 3x to the 7th with respect to x, and it's 21x to the 6th.
1x to the 6th. Nice. All right. And Fiona, go ahead and pronounce this, and give the answer.
F of x equals 2x to the 5th. And f prime of x equals 10x to the 4th.
There it is. Nice. And let's circle around to anyone who wants to do this last one. Just pronounce it for now, and then I'll help us get through it. Who can just pronounce these 2 things? Fiona again.
G of x equals the square root of x. G prime of x equals
Something. Yeah. Okay. So we need to first convert the square root of x, and this is going to be in our homework tonight. How do I turn this into something that has a power? Because we don't have any rule that deals with x or that deals with a radical, but we do have a rule that deals with exponents. So let's turn this into an exponential form. So how do I rewrite square root of x? We just did it up above in our notes on the front side. Andrea, go for it.
X to the 1/2.
X to the 1/2. Do you mind taking the derivative of that for us as well, Andrea?
Would be x over 2 to the negative 1/2.
And negative 1/2. Yeah, there it is. Another way of saying that is 1/2 x to the negative 1/2, but x over 2 is the exact same thing. I think it might be a little bit clearer in our notes if I do it this other way, though. So while you 100% are correct, I'm going to just do it this other way. What happened to my 1? If I scroll down and scroll back up, is it there? It is. Weird. 1/2 x to the 1/2, negative 1/2. And Another volunteer, how do I get rid of this negative power if we needed to? Because again, this is all multiple choice based and they probably will make it as hard as possible and not just give you a negative power. You need to be able to convert this to a positive power. And also not only a positive power, but also not a fractional power, but another radical. So how do I convert all these things away? Get rid of the fraction, get rid of the negative. What does this turn into? Okay, it's the very first thing that we did in our notes, right? If I have something with a negative in the top, I bring it to the bottom. That's why we did our practice at the top. So help me, I have a negative in the top. I need it in the bottom. Chris, help me. I still have the 1/2. What happens to the x?
Let's see. Wait, would it just be 2? I'm just gonna take a guess right here, right? Would it be 2 over x to the 1/2? No.
2 over x. So the 2's are already in the denominator. So it's 1 over 2. Where does the x go? Top or bottom? Numerator or denominator?
Denominator.
Denominator. And what power do I have now?
1/2.
1/2. Thank you. And then another final volunteer. What is our final form to get rid of the 1/2 power and turn it into the radical form? Let's go with Teflon.
Would it be 1 over 2x, square root of x?
2 squared of x. There it is. So all of these forms you need to be comfortable with. You don't know which one multiple choice is, or the multiple choice answers are going to be giving you. Just be familiar with all of them. All right, and that concludes our notes.